Consider the function f of x equals 2x squared minus 8x plus 2 on the closed interval from 0 to 8. The absolute maximum of f of x is at x equals what? And the absolute minimum is where? All right, so let's take a look here. So first off, this is a parabola, so it's only going to have either a maximum or a minimum. It's not going to have both. Let's see what we can find. So first off, absolute maximums and minimums can occur on the any location where the first derivative is equal to 0, so we have critical values. So I'm searching for critical values first. So the derivative here is 4x minus 8, and if I set that to 0, 8 equals 4x, or x equals 2. And that is on this interval, so that's a good possibility. So we have different x values that we need to check, and we'll calculate the y values for each of those, so f of x. So x equals 2 is one that we need. Now, there are no values that would lead to the first derivative being undefined, so we don't have to worry about that, simply because this is a continuous function. Okay, so we need to test this value and the endpoints of the interval. Now, the test is pretty straightforward. It's just a matter of plugging values into the function. And the easiest way of doing that is to use a list and plug those values into that list. So I'm setting up a table. X equals 2, f of x is negative 6. At 0, the function is 2. And at 8, the function is 66. So this is the largest overall, so that's my absolute maximum. This is the smallest overall, so this is my absolute minimum. All right, so relative extrema, you can only have one here because there's only relative minimum or maximum. But because we're on a closed interval, you can have your absolute minimum or absolute maximum at the endpoints of your interval. So here we have both. So the absolute maximum is 66 at x equals 8. The absolute minimum is negative 6 at x equals 2.